I received a comment on my recent golf course video saying that it's a classic example of correlation doesn't equal causation. And they're absolutely right. The study only found correlation, and I stated that in the video. But let me explain why their argument misses the bigger picture. The commenter points out that golfers tend to be older and therefore would be more susceptible to age-related diseases such as Parkinson's. And that's a fair point. The researchers did match cases and controls by age and sex, so age was accounted for in the methodology. Critics have noted that the matching wasn't perfect across every variable. But here's what no confounding variable like age can explain. If age or any other background factor was driving the risk of Parkinson's near golf courses, then you would expect equal risk regardless of how close or far someone lives from the golf course. But that's not what the study found. The study found that the further you live from a golf course, the less likely you are to develop Parkinson's. That's a dose-response gradient. Age doesn't behave like that. Distance from the source of a chemical exposure does. And here's what connects the golf course research to a much broader body of evidence. One of the most commonly used pesticides on golf courses is 2,4-dichlorophenoliacetic acid, or 2,4-D. And Johns Hopkins Medicine, along with some other researchers, have identified 2,4-D as one of the herbicides linked to an increased risk in Parkinson's. Now, granted, that is still just correlation, not causation. So why don't we have a causation study done? And the answer to that is it wouldn't be ethical. The gold standard to prove causation is a randomized controlled trial. And to do that, you'd have to expose someone to pesticides for years and then see if they get Parkinson's. And no ethics board is going to approve that. So for topics like this, the observational evidence that we do have is the best evidence we're going to get. Proving causation isn't really possible. What makes this more than one correlational study is that there's multiple independent lines of evidence that point in the same direction. For example, here's a meta-analysis that found that pesticide exposure is associated with a roughly 62% increased risk of Parkinson's. There's also some studies on agricultural workers that found similar results, and I will be doing another video specifically on agricultural workers. And lab studies have found that pesticides damage the dopamine-producing neurons that Parkinson's destroys. So when occupational research, lab science, and population studies all converge on the same finding, that's not just a coincidence. So correlation not equaling causation is important to remember, but that doesn't mean you can just dismiss evidence because it doesn't directly prove causation. Sometimes evidence needs to be taken seriously even though it doesn't prove causation.